Good morning, everybody. How was your eggs? Awesome? I thought they were just a touch runny. They didn't run off the plate. That was good. How many of you would wake up in the morning and you feel as though you were going to have to give a presentation and your fly would never come up? I dreamed that this morning. And if you're wearing fire engine red underwear, you really get to thinking, oh, gee, many gosh. So we're going to dig into the nitty-gritty of what a strip till system is. And I want to talk a little bit about one of the things that you guys probably are aware of, and that is probably your nemesis, compaction. We'll talk about that some. As Jack said, I'm a soil scientist. I have been now for 44 years. And I really was happy last night when Dr. McGrath said, that soil scientists, when we were in college, so many of us were always thought that we were the underlings because the engineers were the supposedly smart ones. In this room and with you guys that are going to come to the field today, we're the ones that are going to be outstanding in our field. Take a look at from way, way up high in the air. 537 miles or so. Can you find Iowa on that map where you're looking there? I could point it out with this little red tiny dot, but what I want you to do is to think about, we're going to scope in really clear and come down fast. We've already dropped down now for 557 miles up to about 15,000 feet. We're getting closer and closer to Iowa. And even closer now, maybe you can smell the corn pollen. And for me, my voice is normally not quite this deep. Corn pollen and I don't agree very well anymore. When I was a boy on the farm, I never had any kind of problem like with corn problem. But you're even getting closer. Now we're getting closer down right near the soil surface. And thinking about it, because me being a soil scientist, usually having my head in a soil pit, we can even go all the way down to the very door of a wormhole. And as you can see, I don't know if you can see this little tiny red dot, these are leaves and pieces that he has pulled with his mouth and left that right at the door because he likes to stay in his hole. How many of you are aware that an earthworm, especially a vertical boring earthworm, never likes to leave his hole, so he always has his tail remaining in the hole because he'll get lost. Doesn't have eyes, doesn't have a way to be able to find himself back, so he likes to keep his rear end in the hole. So from a viewpoint that I've had for many, many, many years, I like to be able to look at that. You can see this is a vertical hole. I don't know whether or not that shows as well as it could, but there is a trench right here from this midden pile down where the worms go. You can tell I had some coffee. I don't know can you see that over here on this side, folks? There is a trench right underneath where that wormhole is that goes down. A vertical drilling worm will go as far, especially in Texas, 9 feet. He'll move up and down that hole, and he helps make whether it's the Lumbricus testris or the Lumbricus rubellus, those two vertical drilling worms are really burrowing and helping open up holes and create big pores to help get water into that soil profile. But I'm not here to speak about worms. That's Odette's job. Odette Menard, a lady from Ontario, Canada, she talks about worms and she gets all fired up about it. And she knows them very intimately because she goes out at night and takes pictures of them and uses spotlights to be able to do that. But let's get even closer. All of you have heard about electron microscopes and seen what those do. Here's a picture of a scanning electron microscope. But there, boom, 1,500 times magnification, and you're looking at Pseudomonas fluorescens. How many of you ever known anything about Pseudomonas? There we go, one. Anybody else? I'm sure that she could tell you that you do not want to have that in your intestines, because then you become Mount Vesuvius, and you also become Tennessee Two-Trot really fast. That stuff is amazing, but it is in the soil. It creates a lot of opportunities for nitrogen to be able to return to the root systems. So those little tiny guys there that you see that are less than 10 microns in size are on that root surface bringing nitrogen to that plant. So why go from the satellite all the way down to a telescope and then into a microscope? Is for you guys to start thinking about what's little seen is really important underneath. And that's my profession as a soil scientist, to look at what's down below your feet that you guys know some things about, but really what is happening. And we're going to even talk about the itty bitty, which is in microns in size. So that magical world that I like to go down into and look at, I have a friend of mine in western Kansas that says, "I never knew you were that tall, Mike. I've always looked at you down there." In the upper 4 inches of the soil profile, in 1 ounce, there can be anywhere from 4 to 5 billion microbes in that 1 ounce of soil. Start thinking about that, of all those little one-celled creatures, and how many of those guys are in let's say, a gallon of soil. There's more microbes in a gallon of soil than there are people on Earth. Upwards of 2 quadrillion. But here in Iowa, we have anywhere from 18 to 52 families of the microbes that you really are being helped by to get those roots to do their job. But that's not all that happens. The root system of a plant, especially common cereal rye, creates a lot of sugars and polypeptides that it releases and attracts all these little guys and feeds them so that they then feed the root system. As Dr. McGrath said last night, the root system not per se is the big absorber of the nutrient that just because it's in the soil, it's the microbes that live on that root that make it happen. So we not only have the microbes that are doing things, but you have earthworms and amoeba, protozoa, nematodes. All of those then eat microbes. As their little body is crushed and gone through that particular bug, then now we have root food. So it's really, really incredible of what we found out in probably the last 15 years as soil scientists, that we're seeing more and more microbes are what really feed the root system. And they want that relationship. This is an electron microscope. It's actually a scanning electron microscope picture. They used a particular dye to get all of those little bugs to show up. You're looking at a root tip with root hairs. This thing that comes off from the left to right, as you can see over here, those are the little lateral roots off of a root tip, and microbes are all over it. This happens to be one particular bacteria. I don't remember which one it was, but because those roots leak, they're attracting those bugs and they're living on that root and giving that root food. Here's another one. As you can see, without all of those, some of these stain differently, whether they're gram-negative or they're gram-positive. You have the little blue ones, you have some red ones, as you see in a couple spots, and those limey green ones, and some aqua-colored ones. But all of those are so important to feed that root system and to make it happen. So those of you that are using cover crops, whether you're using cereals or broadleafs like sun hemp or some crop like that, it's releasing different kinds of sugars which are attracting different microbes to really make the job done. And what all of that fits into a strip till system, because the predominant microbe that gives you the best effect is an aerobic one. If they go anaerobic, we start seeing disease potential that really come back into a system. So that's why strip till makes quite a bit of sense. So it's not just organic matter anymore, ladies and gentlemen. It's really zooming in and starting to have a better idea of the microbial action that's going on in that particular soil profile. Let me name off a few of them. Actinomycetes. They work organic carbon materials so they can release nitrogen. Alpha proteobacteria. Now, I didn't say anything wrong or nasty there. Alpha proteobacteria convert long and short carbon sources, predominantly making phosphorus available. The bacteroides, as you can see, they give you the micronutrients, such as zinc and copper and sulfur. Well, sulfur is a secondary, molybdenum and manganese. The penicillium, they extract P, or phosphorus, from the labile carbon pools. Spartobacteria, again, another one that supplies it. So as you guys are using cover crop systems, or you're using a real sugary plant like corn that you're growing, we can really excite some of these bacteria to help make your root system function properly. But again, remember, we have to have oxygen to make this happen. A few others. Beta proteobacteria, such as Burkholdia, Nitrospira, Nitrosomonas, Neisseria. Now, those guys are bad dudes. Neisseria usually don't like a whole lot of oxygen, but look what they do. They bring gonorrhea to people, or meningitis. Not good bugs. So no wonder, I don't know if any of you have ever had the problem. You get into soils that have a lot of pine needles, and if you have any kind of allergies, you'll watch your skin deteriorate on your fingers. Neisseria. Not a friendly little bug. Then there's these. There's 2,700 different species of Firmicutes. And Firmicutes, as you view, and what we have done, I think, is a disservice to you. We have promoted the idea that nitrogen, nitrogen, nitrogen is your answer. Firmicutes love nitrogen, and they'll start taking over, and we then get a biomass of microbes that are more Firmicutes, and then a lot of the other guys that I showed you back here, some of those are lost, and we don't have very many of them to help you get your phosphorus, potassium, zinc, sulfur created and get back into the soil profile. So you can see some of those species that are Lactobacillus clostridium, another one that is really good, streptomycetes. Where did we get some of the streptomycin? It came from the soil. And they're the ones that give off some very pleasant soil aromas. Remember your grandfather that told you when you went out and got on the plow, the actual moldboard plow, and he said, smell that soil, that's good, rich soil. It was streptomycetes that were being broken down. So I wanted to, you've had breakfast. I wanted to give you a chance to see whether or not your stomachs were tough. Right there. Now that's not bad stuff. It's just that the microbiology, when I went to college back in the 1800s, we didn't have very many microbiology courses. We had 2. And if that would have been a study that was a lot more advanced like it is now, I think that's what I would have gone into, because, ladies and gentlemen, this is what happens in the soil that really makes things work for you, because they're the ones that are accessing nutrients and being provided to the plant. That little phosphorus granule is being actually attacked by bacteria and worked on to make a created product to be available to the plant. I wanted to tell you about one of the things that's really important in bacteria and their survival rate. It's your soil pH. Who's going to be what, where, and what communities are they living in? Firmicutes. Here in eastern Iowa, they like pHs of 5.5 to 5. Actinobacteria really create opportunities for nitrogen, 5.5 to 6.2. Bacteroides, 6.5. And the acidobacteria, they do best in higher pHs. Here's another one that is really important in helping getting products available to the plants. Pseudomonas pudia. In your belly, not a good thing. In a stomach of a cow, wonderful, because that's really what helps break down cellulose fibers to get the cow energy. So whether you're looking at a slightly acid soil or a neutral soil, knowing some of the things about who does what in that soil profile I think is effective to help us know of whether or not we've got a soil profile that's really going to do a better job for us as we till with a strip till machine. This next slide is very busy, but I want to be able to highlight something before I leave the issue of microbial activity. Boom, wow, loaded with stuff. You're looking at, on the left-hand side, those that like the neutral pH. In the upper right, that quadrant is bacteria that like low pHs, all the way down to 3. In the lower right, those are pretty much medium. We're talking about 5 to 6. So those bacteria, if your pHs are changing, or you're going to have an idea of who's doing what and whether or not your soil profile is going to work for you. So I want to focus a little bit on nitrogen quickly. Under all of the millions of acres of soils that we have, microbes only work in the upper 10 to 12 inches predominantly. If you're down below that, we're going to be looking at anaerobic conditions. There are over 400 different species that really facilitate N. 8 different pathways are being able to use to create that. And then there's the archaea bacteria. They are microbes that do not have a nucleus, just so you know. So you can see that there's about 450 different species that are really creating the activity to get nitrogen available to a plant. The most effective most effective pathway for microbes to do their job is habitat, that's the soil environment, plus temperature. I don't know if some of you I've said before, and I talk a lot about it, corn roots like to grow between 53 and 63 degrees Fahrenheit. So when that temperature's there, we can get a certain number of bugs to do their job. The next most effective pathway for nitrogen to be available to the plant by microbes is habitat plus precipitation. So water's important. Then after that is habitat plus organic carbon. So the buildup of what we want to do as we're trying to return the soil, the residues that we leave on top, that's important. Then lastly, soils and pH. Then there are those predators like amoeba that like to eat bacteria. A little bit about phosphorus, because they're the kind of main two here, nitrogen and phosphorus. Aspergilli and penicillium, pseudomonads, bacillus and spartobacteria, and some actinomycetes and the other names that are there. I'm going to get my tongue all twisted up, won't be able to say another word. All of those are really what help get phosphorus available. Now, I'm going to bring this to a point. What you're looking at here, ladies and gentlemen, is what do I know whether or not I've got these kinds of critters in my soil profile? There are several labs in the United States that now you can take a soil sample. It's usually about a quart in size. You got to put it into a special bag. You got to cool it and send it to these labs. And each sample costs you about $250. But if you want to know what your soils have for bacteria, we now know that we can send that and you can get a report back to what you have. But not very many soil scientists can give you a good idea, or your field agronomist, what's going to help you. So that's why I wanted to be able to share with you this morning what you have when you get one of those kinds of tests. And I would recommend it if you're really looking at whether or not your soils are doing what you want, even with your cover crops that you're doing, and strip till, get some of this done. And it's well known that mycorrhizal fungi are the ones that really help you get a lot of phosphorus available to the soil profile. How many of you know what mycorrhizal fungi do? I see a few hands. I'm going to be quick about it, and then we'll talk a little bit about it out in the field today. Mycorrhizal fungi, they create a spore. I'm going to get tangled up in here yet. They create a spore that lives in the soil profile upwards of 15 to 20 years, some of them even longer. And as the root grows by it, it's releasing secretions and excretions. The secretions are helpful. The excretions are really, it's kind of the waste material that's being dumped off the root. What they do is that within a short distance, upwards of a ½ inch away from that root, that spore is excited, and it sends out what they call an oppressor eye. I don't know if you've looked at really close at what the mosquito proboscis looks like before he pokes his nose into your arm and then gives you a stab, and then you got a skeeter bite and you're trying to scratch it. That oppressor eye then reaches the root and sends in a substance to irritate the root. It lubricates it, and now it goes in and starts its new life inside that root cell. And then what it does when it matures a little bit, it sends out a hyphae, upwards of 4 inches long, and now it feeds its host, because it's a very symbiotic relationship. And mycorrhizal fungi is very, very important for phosphorus. In fact, corn has to have mycorrhizal fungi to really do a good job of uptake of phosphorus. So if you do too much tillage, we can obliterate mycorrhizal fungi. A little bit about phosphorus. It becomes better known that we also need to know about our concentration of iron in the soil, and also how soil temperature is going to help break down the carbon to be able to make it soluble so that phosphorus is available. I don't know if this is a well-known fact to you. You add commercial pea, especially in the West, where I live, we even have less. It's about 30% effective because it will fix very, very quickly. In a high calcium carbonate soil, phosphorus can fix in approximately 90 hours, very, very quickly. Most of the good guys are aerobes, and I kind of wanted to share that and stress it a little bit. So I've muddled up your brain waves. Not that just because you ate too much bacon this morning, but your brain waves have been muddled a little bit. My reason is to give you an idea about what's going on below your feet. Because as you saw in one of the presentations, if you looked at 3 big intersecting circles, where is soil health? And soil health is a combination of soil health, soil tilth, soil quality, soil biodiversity, and soil life. And I think strip till is part of the game. So a little bit about soil tilth quickly. To really know whether or not you've got really good soil health and soil tilth is pore space. And we're going to talk about pore space out in the field. There are 4 different sizes of pores: 2 to 5 millimeter, 1 to 2 millimeter, 1 millimeter down to 2/10 of a millimeter, and all of those pores that are less than 2/10 in size. You can't see those with the naked eye. Which one of those you suppose is the most important? Anybody got an idea? Which one? All of them? Yeah, that's true. The medium-sized pore, which is 1 to 2 millimeters. The reason is the tension, here comes my soil physics, the tension of the soil and the tension of the root that's trying to bring the water away from that soil profile is most conducive at the medium-sized pore. And all of the studies and hundreds of the holes that I've dug and looking at pore space, strip till can help advocate the medium-sized pore better than no-till and better than conventional tillage. So you're in the right place, guys. Tillage and organic amendments and fertilization all can lead to helping make this be a positive impact, or it can also have sometimes a negative impact. So let's look at a little bit about pores. There's a vertical pore that comes down through here where this yellow is showing. You can see this is about 1 centimeter in size. This is then a micrograph that shows you the clear lines are where the air is. You can see where the pores are contiguous. Same thing over here. You can see that is stab and hold that thing still. That is a vertical pore that's going way deep in the soil profile. This is approximately 4 inches by 4 inches, 1 decimeter. But again, the 3 main pore sizes are large being 2 to 5, medium 1 to 2, small less than 1. So you can get an idea that if you start getting those pores to block, then we don't have good oxygen and carbon dioxide, carbon monoxide, the sulfur and the nitrous oxide won't move in and out of the soil profile. When we get a compacted soil, we got problems. Hello, there we go. With strip tillage, I've observed, as Jack said this morning, I added it up and changed it this morning. With the pit that I dug and the help with my buddies, I reached 1,650 just the other day. And in that, looking at the chance to help porosity will help your soil be more healthy, have better soil tilth. We can help improve aggregates to be stable, and we're going to look at those this afternoon. We're going to aid and abet fungi, mainly the mycorrhiza, and we're not squeezing and smearing the soil when we do vertical type strip till. We can change the way roots will grow. Instead of a root coming down and making a right-hand turn and then never being able to get deeper in the profile, strip tillage helps do that. But we're trying to help this becoming living in harmony with all the things that I was talking to you about bugs. It's all to capture the thought that we're going to go into here about providing a good start for the plant, having a healthy root system so that we can get to a potential. Are roots even important in the first months of growth? Oh my, heavens to Betsy. When we're trying to reach a root-to-soil interface that's up to 190 times larger than the leaf space that we have, I think it's incredibly important. Because I've been able to measure it. It takes about 8.5 hours to do this. I remember my supervisor at one time saw me out there counting roots, and he made tracks to get away from that because he said, I don't want to be here. It takes 8 hours to measure a full root system, and you can measure underneath a corn plant upwards between 25,000 and 38,000 linear inches of roots. How many feet is that? It's over 1/4 mile. Under one root system with a plant that's 108 inches tall, we have a root system underneath that's 231 times larger than the plant is above ground. So what's the big whoop of this? Too much tillage, poor harvesting techniques, all are going to cause us problems. This is the big whoop. It all leads to a very dense, non-porous soil, wrong microbes, ponds up, runs off, atmosphere loses nitrogen. We've got a poor root system, and it creates compaction. Here is a map of compaction. I colorized it a little bit. This is after, you can see right where that little black mark is in the middle. Hopefully this will show. It's right somewhere right in the middle there. That's where the till zone was, and this soil compacted immediately right back. So where you can see the red and the yellow, we're upwards of 3 megapascals, which is a measurement of force. That soil is very, very dense. But the root system could go right down the middle and eventually get deeper into the soil profile. This is a map of compaction that is 16 feet wide. I dug a trench to do this because some growers knew in North Texas that they had some compaction problems, and they were trying to figure out what was going on because they knew that on either side of a tractor, they were losing yield. He was averaging about 250 bushel corn, but where those 2 rows were that were compacted, it dropped all the way down to 215 bushel. So he was losing yield and wanted to improve that. So now, as you can see where the pink is, this is on the left side of the track, or this is the dimension of the planter belt on that planter. It was a 48-row planter, 20-inch centers. And here's the other side. And here's the one from the previous year. There's the one from the previous year to that. You see how that compaction was in there, and he needed to make a change. So what did he do? He got smart, pulled his strip till rig out, and went back to work to get it done. But you can see how high the megapascals were going. When you get up above, actually above 8.5, we got some really dense soils. That's probably approximately 500 pounds per square inch of force that it's going to take to get through that. We at Orthman are doing some work with the Ohio State University, I'm sorry. There's OSU for Oregon, there's OSU for Oklahoma State, and then there's Ohio State. I like to tease those guys about the Ohio State. You can see on the left is a no-till situation. In the middle is a strip-till system that was 4 inches deep, and then on the right, strip-till down to about 9 inches. That's in the yellow is giving you an indication that it has been broken up so that we really get an idea that we're improving it. Again, this is done in pounds per square inch, but you can see how that is making a difference. And then I highlighted it and showed what the root system looked like in that particular profile. On the left, again, is the no-till situation. The roots came down to about 3 or 4 inches and then laterally started to spread. One of them was getting down, but you can see on the right in the strip-till system, we were getting a full root profile. Incredibly important if we're wanting to make things happen. Another way to look at it is what happens in your saturated conditions, and we're going to do this afternoon, is to use this little Torvain tool. That Torvain tool will give you an indication of what the roots are going to be up against in a saturated condition of whether or not they're going to be able to go through it. It's something that is really important, especially to an engineer. He uses this a lot in wet concrete, whether or not we've got the right kind of system set up for the concrete. Well, we're wanting to know whether or not in a wet situation, how bad can it be for my roots to grow? So let's look at a little bit of research from this year. I used the Torvain tool and went down 2, 4, 6, 8, 10. And the test value that comes off of the Torvain was from 0.75 down to 2.5 in the strip till. And then in the conventional tillage, broadacre, you can see that it was similar in the upper 2 inches. And then by the time we got down to 10 inches, it was upwards of 5. Pounds per square inch, when it's saturated, you can see it was ranging from 10 down to 35 in the strip till. But in the conventional till, it was ranging from 10 to 70. In a wet condition, anything above 50 is not a good deal. Now, I converted that because putting a mathematical expression to this, ladies and gentlemen, and you know that corn has a certain amount of energy to grow roots. If it has to exert over 6,000 watts of energy, it's in trouble because a plant compartmentalizes and says, I've got so much energy to grow roots, so much energy to grow a stalk, so much energy to grow a leaf, so much energy to put into sugar production, and if I only have a allotted amount and I can't get through very early on, then I have to exert 6,000 watts of energy, I'm in trouble. An incredible way to start looking at whether or not we've done the right kind of job underneath the soil surface. So as you look at where I've circled those, above 6,800 watts per hour that plant is having to exert, man, we got an issue that we're going to try to deal with. And strip till can help come and function that. So let me summarize. We know that microbes are incredibly important. We know that as a soil nerd, which I am, and my wife has said that now that she says she's known you for 47 years, you are a soil nerd. And my daughter, who is a lab technician in a hospital, says, it's all right, Dad, I'm a nerd about poop and pee. So making nutrients are really very important when we start thinking about bacteria. I wanted to share that with you. With strip till, we can aid in the stimulation of worms and bacteria to make it happen so that the underground critters are doing their job. The pH of your soils is incredibly important, and that's one of the tests that you do frequently in your soil test. but it dictates who's in the microbial world. It also dictates when you apply and put a cover crop in there, is it helping you create more bacteria and the right ones to do the job? Soil compaction is a big deterrent of soil health. Strip-till methodology helps improve that so that we can get soil health to be much more helpful. Starting a root system is vital, absolutely vital to get a plant to grow, because by the time the plant is 45 days of age, it's the very first critical period in that plant's life. And what you're looking at is what at the 45th day in a corn plant? What is it doing about that time? Number of kernels around the cob, that's what it's setting. That cob is approximately 10 microns in size at that time. But you're getting the idea that that's the first time. And if we don't have a root system in the first 45 days, you're out of luck. Incorporating more and more roots that are living, whether you're using a companion crop or a cover crop, when it's possible, or if it's even feasible, is a good idea. You get into the western part of Kansas, the northern panhandle of Texas, it's really tough to grow cover crops. Because in the spring, if they get 1 inch of rain, especially in North Texas, really, really a tough deal. Lastly, knowing what your soil parameters means something to quantify soil health. And we wanted to talk about it. It's just not planting a cover crop to make it happen. It's whether or not your soil is going to be able to be conducive to doing what you're after. Because we all want to finish well. And I hope that, Jack, we've got a time for a couple questions. I'm going to be around for a little bit, and then I'm going to scoot and go to the field because there's a few last-minute details I want to do. Hopefully, the ones of you that come this afternoon, you're going to get a taste of what it's like to be with a dirt digger. And I thank you for your attention and your keeping tuned in this morning. Thank you.
Thank you, Mike. We do have time for a few questions, so if there are some in the audience that they'd like to ask Mike, we got one right over here.
How does the fungicides affect the fungi?
Repeat that.
How do the fungicides, the corn fungicides we put on, affect the fungi and the microbes?
I didn't get your question. I'm sorry.
How do the corn fungicides that we apply affect the fungi and the different bacterias?
Okay, his question was, how do fungicides affect the fungus and the bacteria in the soil? They usually aren't the best, but most fungicides you're applying to the leaf and they don't get to the soil that quickly, so it's not as big of a problem that it could be. At least that's what I've noticed. Does that answer your question? Okay, thank you. Got another one?
Over here, Mike.
Mike, what have you seen over the years of fertilizer placement with the strip-till system? The benefits and how much cost can a guy save on fertilizer by placing it in the strip versus broadcasting?
So if you're placing fertilizer, hopefully, as Dr. McGrath said last night, precisely, with precision, which any of one of you that believe that you're using a spin rig and you're doing precision application because the guy tells you are, you were saying, Mark, then that you were wanting to know whether or not you were doing good when we precise place. Yeah, we are. Because if you can put it in position for that plant root to come by it, and then the bacteria are doing their job, we're going to get good out of it. The effectiveness, we know that if you're spreading it all over the soil surface and you're not getting into the soil profile where the roots are, we're going to be in trouble. The effectiveness is probably less than 25%. Does that help answer your question? Yes, sir. Speak slow enough because my tinnitus this morning is just ringing like crazy, and I'm wanting to make sure I hear you.
So earlier you talked about the 190 to 240 times the root linear inches
Yes.
underneath the plant versus what you're seeing above the plant. Do you see any differences between a conventional tillage, no tillage, maybe even strip tillage? Sometimes I think there's a concept of roots for the sake of roots, but sometimes, like, do you see an efficiency thing with strip tillage? Are those roots working more efficiently? You know, would a 190 times rate with a strip tillage give us some benefit there versus a conventional tillage system? Or can you comment on what you see between tillage systems on that ratio?
Yes. He's asking whether or not in different tillage systems will we see bigger root expression and how much you have compared to strip tillage versus no-till versus conventional tillage. Yes, I did that, and I still like to do it, but everybody then, when I need a little bit of help, wants to run away, because who wants to count that little tiny root that's only about half of an inch long? I have found that under strip tillage, we probably get the deepest root expression, and also then no-till comes second, and probably broadacre tillage comes third. What we'll see is anywhere from, like I said, 190 times upwards of 200 plus in a strip till system, and it's going to be less in the no-till and even less than in a conventional system. Due to the fact that strip till helps, hold on to your question, helps bring more vertical expression to the root system. Now, on top of that, ladies and gentlemen, root architecture under different corn types is very, very important. I know last year or 2 years ago when I was here, we talked about root types. You can get up to, Dr. Martin Bone at the University of Illinois has been studying root types very closely by using fractal geometry. And Martin has shown that there are upwards of about 6 different root architectures. And I have found 4, but there are some that will go deeper than others, and some will just look like an umbrella and they never go any very deep. So having a chance to help get more vertical expression is, I believe, is very important, and strip till helps facilitate that.
I think we one over here and then one over here.
So it's,
Sorry, they got bright lights right in the eyes.
yeah, I can see you fine. So,
You can see me, but I can't see you.
that's right. That's good. So it's exciting to listen to you speak. Somebody who's excited about their occupation and in things that you can't see. That's congratulations to you. Thank you.
Oh, thank you.
And the one slide that you put up there, and you kind of going over quick because you got a lot of information. It said you had only 30% of your phosphorus is, and I just need you to repeat that, is only 30% of the phosphorus you use available, or is that how that slide read?
It's a statement of 30% effective.
Okay. So you have to put lots on, is that the idea?
Well, if you put on more, you're saying that's going to be helpful?
Right, that's right, is that true?
Normally not.
Okay.
Placement in line where the roots are going to be is going to be more helpful than anything else of why you want your phosphorus to be underground, because phosphorus, if it moves more than a half an inch a year, it's amazing. Now, if we were dumping some kind of acid on top of it, we might get it to move, but it rarely moves very fast at all.
Thank you.
Sure. Over here.
Yeah, so I got a couple-part question here. I'm from North Dakota, where we have really high pHs and everything, and like you said, the pea gets tied up right away in 90 days or so, or 90 hours. So putting in a strip is going to be more efficient. So my question is like how much more efficient is it from going from a broadcast to a strip, and in those high pHs when we're talking 8 or so, like what else has to be done to make that available, I guess?
Wow. How to get to all of that in one question, huh?
You can summarize.
It'd be a lot more fun to sit down and just talk, I think, because how to express that, I'm sorry, I'm kind of at a loss because I'm trying to think.
What's like the rule of thumb from efficiency of going from broadcast to strip till then, I guess?
What's my rule of thumb of what again?
Efficiency, like P use rate or whatnot. Like if I do 100 pounds broadcast, what can I figure for strip till and still get the same results?
How much can you put on? I have found, thank you for helping out a little bit, my interpretation from 50 feet back up here, there was a few feet that got caught in the way and the whole works. I really see that we can tell more when we start looking at soil test and then plant parameters, that we can be looking at, instead of 100 pounds, we can drop all the way down to 60. Strip till, because we're getting more zone closer to the root system instead of broadcast on top, usually we become 40% less in all our application needs. Now that's a rule of thumb. And it's probably a big thumb that got run over by a tractor, but that's how I look at that. Does that help any? Okay, I want to make sure I'm not just stumbling around up here. How are we doing for time, Jack?
We got time for a couple more. We got another one right here for you, Mike.
Mike, if your children or grandchildren picked a carrot out of the garden and ate it without washing it, would you be upset?
No.
That's efficient, baby.
Another one over here.
Yeah. Our Northern Iowa Research Station at Kanawha, here in Iowa, had an 11-year study, and it showed no significant difference between broadcast P&K and zone application. Is that true? And then another question is there such a thing as luxury consumption? So if the P's there in a higher state like you're talking about, could it just be luxury consumption?
Well, to answer your first question about in that 11-year study, that might be true for your area.
That's what I'm wondering, you know, Clarion Webster.
I've had the fortune of being able to travel over many, many countries on this earth, and I have found that placing phosphorus is still very effective. Secondly, let's come back to luxury consumption. A plant, normally a corn plant, for instance, requires a certain amount of P, and then it will bring it into its root tissue and use it. What it doesn't need, it doesn't go after. So I don't know whether or not luxury consumption is really the term that I would use, but I know with nitrogen, luxury consumption is very often a thing that we see, yes. But I don't know about it for phosphorus.
They had another study and showed that like you said, the plant only uses what it needs. And my concern was I was putting on 3 tons of chicken litter prior to my soybeans, and I didn't know if the soybeans would somehow use too much P&K up from that and wouldn't leave enough for my corn the next year.
I don't know if I can help you on that one. Not being a soil fertility specialist, I dabble in that, but I love the soil physics side of things, so we'd have to ask a soil fertility guy to really help you out there. But a good question. Thank you.
Thank you.
Oh,
There's one back there.
Do we have one more?
Way in the back.
Way in the back. Quick question. Do you see much difference between Coulter-type tillage machines and shank type in the strip till environment?
Do I see a difference between a Coulter machine and a shank machine in what regard?
In strip tillage, is there much of a difference? Is one better than the other?
You bet there is a difference. And if one's better than the other, you bet there's one that's better than the other. I believe done correctly at the right time, the Shank machine will outshine a Coulter machine. Coulter machine has its place, but a Shank machine will outshine due to the fact of what it does in the ground. We're going to talk about that a little bit out in the field. I could go into it for a couple hours, but I think that there's a lot of other speakers that want to get up there and give their presentation, but yes, I do believe that there is a difference and that there are preferences. That help?
Yes, sir, thank you.
Okay. Thanks again for your attention, folks. I believe that you've been a good audience. My entertainment of my fire red underwear are not behind there, so I'm okay.